my thing now?
Yeah, I
You know what
really
mean?
do. How do you worry?
Man,
That's kind of scary.
you know,
You go to write on the whiteboard?
you have to use analysis.
Oh, okay.
It's like a rule. Maybe we have to recalibrate or something? Do you think that's the trick?
Yeah, I think so.
Oh, this is not good. I can already tell. This is not good. This is not the issue. See, it's not, I'm not even touching the board, but it's, what do we
Is
do?
this the first day?
What do we do?
Oh, I don't do psychology. I don't know.
I have another pen, but I don't think that's gonna work. What do we?
Yeah.
Okay, this pen seems to be, at least for now, working. Let's see. I take it back. No.
Nope. Yes.
All right, I think it's working. Cross your fingers.
Oh, God. It doesn't work. This thing does. It doesn't work. It's so ugly though. Hi, Leo.
I'm excited. I love math. I don't know what you're talking about. Okay, what were you doing this morning? Like, army? Something about the army? What? Should I sit down to wait until you finish?
No, this thing is just ugly.
Mr. K, okay, Mr. Kenny replied to my survey response. Because I thought he would have finished. But that's what people say. So I was honest about when I rated my
Wait,
essay.
come here. Can you read that? Yeah, I know. You know what? I don't like anything here. Take it.
I wrote honest things.
Okay.
I wrote honest.
Let's say that I did the identity matrix 1001.
Wait.
Okay.
There's
so
not a space.
you want to dilate something.
There's not enough space.
Then what do you need to replace? What? What number? What number precisely? No, you want to dilate it. You want to replace it with? The number you dilate.
I didn't do that.
What have you done? What have you done?
Is it messy?
No, leave it.
Is it working?
No, it's zoomed in.
Is it working
Oh,
now?
thank you. Okay.
They do nothing.
Okay, that's
Okay. But in an identity matrix for a dilation, the two ones are equal and the two zeros, right? I didn't know that.
How do I undo?
I didn't know that's a
I know it's really hard.
Yeah, this is
Okay, I'll try a second time.
Look at that. That's better.
Nah, yeah. How about we just write the answers on the board?
Yeah.
On the whiteboard. Sorry,
Not neat.
Sorry, this is an ongoing issue with my board. I don't know how to fix it.
Yeah. No. Okay, I was telling Grace.
Beautiful.
I love math. Especially.
All right, number 1 and 2, I think everyone has, right? Eric, you can put it on the board if you like, number 3.
Number 6 giving me a headache. Deceptively necessary.
I wrote all my reaction papers during lunch this year.
In italic.
And then I didn't have one.
Did you need help with that?
Yeah. But I didn't think it's okay. I mean, email. I had like the smiley.
Yeah.
Really?
So number 3 is up there now. Thanks, Eric. So we have a, I know that some people are confused about the dimensions of the matrix there, but we have a 2 by 1 here, right? Here we have a 2 by 2, right? Do you agree that this 2 by 2 matrix times this does give you the desired vector result, right? BA, not BA. Yeah. No, we don't. Yeah, so we just want to say, if you give me a point, what point does this output? That's all. Yeah. Yeah. So I know you're. Some of you might be confused about like where'd the I go and all that. But I just want to make sure we're clear. The emphasis today here is. Thank you, guys. The emphasis today is on the fact that we can represent these kinds of transformations in a number of ways. It should have even felt familiar as you were doing the homework last night. You're like, wait, I feel like just recently we've been rotating and dilating things, maybe even by multiplication and whatnot. So it turns out that I guess multiplying by a complex number rotates and dilates, but so does multiplying by an appropriately chosen matrix, right? This should remind us of like, boom, it's all flooding back, right? What was it, 3 days we did on matrix transformations and stuff like that at the end of last unit. And then, Ivy, I saw you had something to contribute on number 4. What's going on there? What do we require? What did you say you required for a general matrix to be a rotation and dilation? What do you demand? If I just give you any 2 by 2 matrix, will that be a rotation and dilation? I guess not, but. Yeah, did you catch what she just said? Say it again, Ivy. A is A. B is negative B. Okay. I guess. Yeah. What do I require of this matrix here? Can we talk in terms of these 4 letters? So, like, what do you require? You want what to be equal to what? There's nothing special about our. Yeah, we want A and D to be the same thing, right? And then what else do you want? Yeah, you want those to be the same, just like off by a negative, right? Then you want them to be opposites of each other. So apparently, well, I guess the claim we're making here is that any matrix you bring me, any 2 by 2 matrix you bring me, that has this property that the 2 diagonal elements on the main diagonal are the same, and the 2 on the off diagonal are the same but opposite, will be a rotation dilation matrix. I guess we're saying that, apparently, right? I mean, that's what we seem to have gotten on number 3. That seems to be the result right here, yes? Okay, so this is an interesting observation. I think maybe people haven't had enough time to think about 5 and 6, so I'd like to make sure you're good on that before we have a discussion about that. Let's actually think hard about 5 and 6. how are we gonna get a matrix that in 5 only dilates and in 6 only rotates, no dilation?
I know there's a the factor is zeros. The identity matrix, the 1001 matrix, where your dial is 1. Where dial is like 2, what would you put that? Magic! Sorry, I totally didn't mean to hit you.
That's right. Yeah, let's. Someone just mentioned something that might be helpful. Keep in mind that r squared is equal to a squared plus b squared. For this one down here too, what else do we know? What else? What other relationships do we have in terms of like theta and r and y and a and b? Or what else do we know? I'm just thinking of like polar coordinates and all that. What else? What other relationship do we have between the angle that relates to angles?
Theta equals tangent -1 y over x.
Yeah, or I'll just write tan theta. Oh, that's terrible. That is terrible. Tan. All right, so just as you're doing 5 and 6, you may want to consider the fact that a squared plus b squared is r squared. I'm just drawing your attention to these are things you know, and that tan theta is equal to y over r, or you could say sine over cosine if you wanted to. A couple of things to think about as you're doing 5 and 6. Okay, remind yourself.
Y over x.
That's what I said. That's what I said.
Minus 2 points on the quiz.
That's what I said. Y over x. If you come up with a matrix or a requirement of some kind that does the trick, let me know.
Well, I have 5.
5, you got it?
A lot of people.
Yeah, no. You can test it and see if it works, right?
Assume x and y are 2 and 4, and then r is 3. So, 2 times b is 6.
B over A. Yeah, I guess we're using B's and A's now. Is that okay? B over A instead? I forgot we're using A's and B's, not X's and Y's. Yeah. A's and B's, right? So think about that number being A plus BI, right?
No, because
Well, what do you want the result to be? Too much. We just need to
that would be a flip or if you did 0 theta theta 0, it would be 180 degree rotation followed by a dilation by theta,
by your vector does nothing.
which is not what we do.
I'm just saying this is a vector.
Here's a hint. Multiplying by what number is that's nothing.
So you're going to give
Questions. They make everything better. I'm going to take these two vectors. Screw it!
scale by a vector. It works. Did you do number 6 yet, or are you chatting about whatever you're chatting about? Well, you gotta think about it. All right. Well, we gotta get through these number 5 and 6. You know. Since not a lot of like. All right, I think a lot of you are overthinking number 5. What's the answer? I mean, it should be clear. Try it on a point xy. If you multiply this by xy, don't you get 2x? 2y? Perfect. Job complete. Mission accomplished. All right. Number 6 is a little trickier, though. Any observations that we want to make about this matrix? Any requirements that you have? If it doesn't scale it at all, any requirement you might have? I don't know. What has to be 1? Everything has to be 1. Yeah, we want. Let's go back to complex numbers for a second. If we want to just rotate it and have no dilation, what must be true about A and B? What do we want R to be? We want R equal to 1, but R is also known as, in terms of A and B. All right, so we require that be true, right? Okay. If we know theta, then what? And this is also true. Then what is A? And what is B? If we know the angle theta, and we know that it's 1 unit long. This is a strange context to have this conversation, but you've thought about this 1,000 times before. I promise. If we draw a picture of a circle and stuff, here's a circle 1 unit in radius. What are the coordinates A, B, if you know the angle theta? Come on now. Fill in the blanks. Give me the matrix. Don't we just want to know what A and B are? My God. Oh.
I had it almost right. Cosine theta 0, 0, sine theta. No, that wouldn't work.
Do I want like some? Give me a 2x2 matrix, right? It does the rotation job, right? Does that actually do rotation? What's A and B?
I know we can say 0, 1, 0, 1, 0 is like.
What is it supposed to be again? A, B, negative B, B, A? Is that what it's supposed to be? So what is that? What are those going to be? I think that doesn't. 22. I think that scales by root 2 actually. Doesn't it? Because A and B are 1 and 1, right? So doesn't that scale by root 2?
Yeah, I'm guessing that.
The magnitude of that is root 2. What are the coordinates? We got to just use it. What are the coordinates of this point if you know theta and this is the unit circle? Come on now.
Cosine theta, sine.
Isn't this cosine theta? Sine theta? Go. What is this?
Cosine theta 0, 0. 50, negative.
Oh my god.
Right? Isn't A cosine theta? We don't want any dilation. If you want, no, don't leave yet.
This is math.